Good morning, class. This is Mr. Roberts with the last lesson for this week. This is section 9.3.1, and I want to start by going back to a previous lesson. I think this was 922, a homework problem number 58. And one of the things we were asked to do in this problem was to graph an inequality with two variables. And the procedure that we had established for doing this back then, and it's summarized in our math notes today in our textbook in 931, was if you're given a inequality like this with two variables, first of all, realize that you've got two kinds of boundary lines. Your boundary line will be solid in the case that your inequality has the or equal to line under it. So this is less than or equal to. It'll be dashed if you look over here on the green one in the case that it's just strictly greater than or strictly less than. It doesn't have the or equal to. So it's pretty easy for us to draw a line, right? We know the two parameters. This line has a y-intercept at 5 and a slope parameter of -1, so I just follow the down 1 over 1 pattern. Once you've established the correct boundary line, either solid or dash, what we do then is we test a region. We test I prefer to just test 0, 0. I find it simplest. If I put 0 into this, 0 for x and 0 for y, I end up getting that 0, because that's what y is less than or equal to 5. 0 is less than or equal to 5 is true, and that's why I shaded the region below. So all of these points on this part of the Cartesian coordinate plane are solutions to this inequality. I could pick any particular x, y, plug in the x, plug in the y, and what I would get would be a true inequality. The thing on the left really would be less than or perhaps equal to the thing on the right. Same thing over here on the other one. We drew our boundary line. Our y-intercept's at -1. We have a slope pattern of up 2 over 3. And all of these points, once I tested 0, 0, it turns out that 0 is greater than, remember x would be 0 also, so 0 is greater than -1 is true, so we shaded everything above. What we're going to do today is start looking at systems of linear inequalities. So that means instead of just one, we're going to have uh, multiple inequalities and look at them together. So today I'm over at my friend Desmos, and I want to look at both of those inequalities from question 58, and we're going to graph them on here. So I can graph y is less than equal to, and you'll see that when you're in Desmos and you do this, you just hit the less than symbol and then hit an equal right after it, and it turns it into that symbol. Y is less than or equal to the opposite of x, or -x plus 5. Um, so this was the graph that I had in question 58. You can see that the boundary line is solid, and the side with 0, 0 did work, so it's everything shaded below the curve, right? We're looking at y values that are less than that. The other one is y is greater than or equal to 2/3. Now I press the over arrow to leave the denominator. You don't want to be putting you don't want x to live in the denominator. If x was down here with the 3, that would be a problem. So 2/3, and then this is times x. So y is, it's not greater than or equal to. It's supposed to be just strictly greater than. There we go. So y is greater than 2/3 x, and then minus the number 1. So you can see now we've got this additional boundary line, and this was the second problem, part B from question 58. You can see that this boundary is dashed, indicating the points on the line are not solutions. And it's divided the Cartesian coordinate plane into 4 separate regions. This region over here is a region where none of these points satisfies either inequality. None of these will work in either one. This lower region down here are inequality or xy pairs that would satisfy the top inequality. So anything down here would be a solution for this one, but not the other, but not this one. Regions up here in this brown region, y is greater than 2/3 x minus 1, would be a solution to the second inequality, but not the first. And then this region here is all the points that satisfies both. So you can see by having two 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 constraints. These are called, we call these constraints. By having two constraining relationships on the plane, we've created four separate regions, and only one of the four regions has points that would work in both. So if I was to consider the point x is 0, y is 2, this point 0, 2 would work in both inequalities. If I was to pick, well, I could do that. So if I put in x is 0, this becomes the number 5, y is 2, 2 is less than or equal to 5 is true. So 0, 2 works for the top inequality. And 0, 2, if I put in x is 0 here, this becomes negative 1, y is 2, 2 is greater than negative 1 is also true. So all of these points, right? And this is why we need to be able to graph these, because it's not my solution. My solution, right, is a whole bunch of different things. There's lots of points that satisfy this situation, and all of these constraints, all of these constraints, there's just two constraints at play right here. These two constraints that are at play tell me where to look for solutions. So I have two more graphs that I want to look at with you. This next one is, there's a system here, y's are less than x plus 2, and y's are less than or equal to 10 minus 3/4 x. So y is less than x plus 2. There we go. And that's down here. And the other one is y's are less than or equal to 10 minus 3/4, get out of my denominator, x. There we go. So it's pretty clear that we can see at this point that the points down here are solutions to this system of inequalities. Any xy point that I pick in the area that's double overlapped would work. So I could say, for example, if I was asked, hey, what's a point that works? It looks clearly like x is 4, y is 2, right? So this point right here is the point 4, 2. 4 plus 2 is 6, and y was 2. 2 is less than 6 is true. With this being a 4, over here I've got 3/4 times 4, which is just going to make this a negative 3. So 10 minus 3 is 7. And again, the y value was 2. 2 is less than or equal to 7 is true. So points that are in the double region here are solutions. So when we just have the two lines, right, we're dividing the plane up into four different regions. But we could have multiple constraints, and we could also have constraints that aren't linear. And I want to look at that for our final example today. So our next curve is an interesting, I think it's the first time we've seen an example of this. This is exponential, right? My 0th term would have to be the number 1, right? So if x was 0, this would give me 1, but then the entire curve is shifted down 6 units. So if I was going to look at just the curve, y is equal to 0.5 to the x power, that's what I would see every single time x increases by 1, right? I end up with half of what I had. So at 0 I've got 1, at 1 I've got a half. Here's a quarter, 1/8, 1/16, 1/32. And if I go back to a negative 1, x to the negative 1 power would make it 2, right? I'm sorry, this is 1/2 to the negative 1 power, or 0.5 to the negative 1 power is 2. And then raise that again and I get positive 4. So that's that boundary, but then it says, well, we're going to shift that whole thing down 6 units. So we haven't done that, but there it is, right? So now here's this x-axis, which is normally our asymptote for these exponential functions. But now, because I've decreased all the y values by 6, this entire thing has been shifted downward 6 units. So you can see what was once at the number 1, right, is now down here at the number -5. 1 minus 6 is -5. And that happened everywhere. Now, of course, we don't have the equation here. We've got an inequality, so I need to switch this out. Instead of y's being equal to, I'm looking for y's that are less than or equal to. So now I've got this boundary, which is different than a linear boundary. The other one is linear. It is y values are greater than negative 2x, and you can see the y-intercept is at 0, and I've got a slope of down 2 units over 1. The question that I want to draw your attention to is when I just had the two lines, right, it cut the Cartesian coordinate plane up into 4 distinct regions. How many regions are here? Well, it turns out there's a lot, right? We've got the region right here that satisfies none of the equations, right? This region that's completely black, if I pick a point in here, it will not make either one of these inequalities true. If I pick points over here, it'll make the top inequality true exclusively, right? If it's just this color, it'll exclusively make the top one true. And if I click read over here in this area, this will make just the bottom inequality true exclusively. And then there's this one where it's shaded with both colors up here and here, and this would work in both. So how many different regions are there? Well, physically there's 1, 2, 3, 4, 5 different regions. So there's 5 different places, right, where we could potentially check to see where our solutions are. Looking at this visually, I mean, it's very obvious that the solutions are down here and up here. So what's going to happen now with the next question? The next question I have for you is what happens when you change these inequalities, right? Where are the solution regions then? And in the homework or class assignment, what I want you to do is I want you to be able to grab these images and post them into your assignment. So let me just show you how I like to grab images from Desmos. I kind of like these boxes to be roughly square in shape, so this is not bad. But you just come up here to the share graph, and then I'll just click export image. And once this is here, if you right click this, or I'm not sure exactly what that is on a Chromebook, but you can either screenshot it, but I'm sure that there's a way that you could right click this and then say copy image. It's kind of nice if you make the lines a little bit thicker, they're easier to see, or maybe medium. But I'm just going to say, oh, look at this size, medium square. Oh, so you can get like a different size for these graphs. So I think a medium square is appropriate for our purposes. And then I'll just hit right click and I'll hit copy image. And now that I've copied that image, what I'm going to do is I'm going to switch over to our doc where we're putting our information today. So this is the form you'll be doing. And this would be wrong, right? Because you can see the one that I just copied was the one for the class, right? So I copied the one where this was less than or equal to, and this was greater than. So this is not the appropriate graph for this, but I want you to look at what happens as you change those inequalities, and I want you to be able to describe I'm going to ask you to describe the effect that changing the directions of these inequality has on the graph. So that's one of the things that you'll see me ask you to do. And the other thing is I'm going to ask you to list just a single xy point that is a solution of your graph. And I say use integers only. So for example, a point that would work here would be in x is negative 10 and y is negative 10. This point is clearly a solution. So I would just like you to say, it got kicked onto the next page, you would just say negative 10 comma 10. But of course, this is incorrect because this is the wrong graph. This is the one that we did. There's 3 variations of this that you need to do. So I'm going to go ahead and delete that. The other thing that's on here is this problem. And this is going to be a little tough. I'm just going to say that these boxes are box 1, 2, 3, 4, and 5. And what I want you to do, 1, 2, 3, 4, oops, 1, 2, Why'd that change? 3. Huh. 3, 4, and 5. Sorry about that. So what I'm going to ask you to do, and I need to figure out why these are. What I'm going to ask you to do is, oh goodness, oh, 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 Google Docs. Okay, it seems to be behaving now. So we're just going to go 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5. And I'm just going to ask you to put the symbols or numbers or values that are missing from these boxes. So the United Nations has asked every nation to write constraints that will best approximate the country's shape. The UN thinks this will help find each country's area. I don't know. Honduras sent in its constraints, but some of its information is unreadable. Okay. So these are like smudges or something. These boxes are things that are unreadable. With your team, and you could call someone, you could get together and share your Google Doc and work on it together and talk at the same time. But this is with your team, determine the missing parts of the inequalities and write them on your paper. So I'm just going to ask you to type them here. And then the final thing I want you to do is put a photo of your homework below here, questions 58 through 64 today. As is usual, I'm going to be providing all the answers below and links to my video solutions. I really encourage you to take ownership of your own learning and be aware of what you don't know, and watch things, watch me do things, watch other people do things, so that you can figure out best what's going on. And I will be available again on Friday at 10 o'clock our normal time for my help session. And I'm also starting some small groups. So if you're interested in working in a small group, probably like 5 students at the most, and you just would like some additional help, or you've got questions that you'd rather ask at a time when not everyone's going to drop in, or everyone can potentially drop in, but just you or a couple people, let me know by email and I'll set that up. All right, this is Mr. Roberts. We're at 17 minutes, 25 seconds. I hope you have a good day.